Thank you all for being here. It's a pleasure to have the opportunity to be here with you today. I hope you'll enjoy the presentation and perhaps learn something new. My name is Miroslav Mikluš. I work as a Chief Product Officer at Pantheon Tech. And today we prepared a presentation about the integration of two open source projects, SONiC and OpenDaylight. As we move through the presentation, I'll be highlighting how these two platforms work better together to enhance network reliability by leveraging SONiC as an efficient data plane and a control plane, and then the OpenDaylight, in this case, providing a powerful automation and management platform. I'm sure you already heard about SONiC, so let me start with OpenDaylight first. OpenDaylight started as a greenfield project without any code drop at the beginning. So during the initial months, there was lots of discussions about how the architecture of OpenDaylight will look like. Some of the community members were pushing the flow-centric approach and modeling the APIs around OpenFlow. Back in 2013, the OpenFlow was still a thing. And OpenFlow was considered at that time as a synonym to SDN. The other proposed approach, the ODL architecture, was built around model-driven architecture based on Yang data modeling language. The second approach was adopted, and therefore some of the initial projects was about understanding of the Yang specification, translation of the models to Java objects and the programmable APIs, and actual data store that is implemented in the OpenDaylight. On top of that, the OpenDaylight community then continued with development of various different protocols like netconf, BGP, PSAP, LIFT, SNMP, etc. You see the timeline. It's not very visible on the presentation, but you can download the presentation after the talk and take a closer look. And on top of these projects, there were built many use cases and integration. So this slide demonstrates OpenDaylight in its best ages. As you can see, there is a lot of projects. Down on the presentation, you see the protocol libraries. In the middle, that's the service abstraction layer. On top of that, lots of use cases and with a few northbound interfaces. These days, the OpenDaylight is more mature. Many of the projects are not active anymore. And currently, most of the contributions are going into the AAA, which is the Application Authorization and Accounting project. And those services in the project, they help improve the security posture of OpenDaylight deployments. And by default, the majority of the OpenDaylight northbound APIs are protected by the AAA infrastructure. The second one is the BGP SAP project, containing mostly the BGP implementation, PSAP implementation, and path computation. So that project contains use cases like BGP route reflector, BGP LS, topology discovery, and the PSAP, the path computation element protocol, as a way to instantiate the paths into the underlying network. Another project is the Yang tools, which is basically the Yang parsing and validation of the Yang models and translation into the Java object. So basically a set of libraries to deal with the Yang models. Then another project is the MDSAL that contains the model-driven service abstraction layer, providing the features like the message bus and the data store features. And the last one, which is shown on the presentation, is the netconf project. And that one contains the implementation of netconf and the restconf protocols with the integration to the MDSAL infrastructure. So what's the role of OpenDaylight in the SONiC world? First of all is, I think, standardization. I'll discuss the importance of standardized APIs later in the presentation. Then availability of various network protocols like netconf, restconf, GNMI, etc. And thanks to the fact that it's hosted by LFN and it's an open source project, it guarantees a vendor neutrality. And again, thanks to the fact that it's basically a platform and its components are available as a set of libraries, it's a really extensible platform that you can build on top of that, and you can create your own applications and tweak the behavior of OpenDaylight for your needs. So back to the SONiC. As you already saw in the previous presentation, there is a couple ways how to manage SONiC. What options do we have? So we can either use CLI, various different CLIs, like Shell, Clish, SONiC CLI, Witish, the CLI to the Redis database, as a few examples of how you can configure SONiC if you are a human operator. Then you could, in theory, use the configuration backup and restore, which is fine for use cases like a ZTP or some failure scenarios. Not very ideal for the daily operations. And then you have another approach, which is agent-based approach. So you could, in theory, build your own agent, which directly speaks to the Redis database and doing the either configuration changes or monitor the state of the individual components within the SONiC. Or, as already mentioned on the previous presentation, there is a structured API available in SONiC. There is still ongoing discussion what Yang models will be used there, but the GNMI as a programmable API is already available in the open source based on Yang and GNMI protocol. So guess which interface would OpenDaylight use to integrate with the SONiC? So the preferred one, which we picked, is the GNMI. And because of its features, it has a well-defined structure of the data. It allows you to version the APIs and the extensibility, so you can add new features by providing a backward compatibility. And if you're using the standardized Yang models, it could provide you a vendor neutrality as well. It gives you a better error handling. So if you have the error handling by design in the protocol, then you can better handle various different failure scenarios. And the GNMI also support the transactional support or the transactional behavior. So if you're sending multiple operations as a part of a single request within a GNMI, they have to be applied either all or none of them. So that gives you the all or nothing scenario, at least on a device level. And it's not mentioned here on the slide, but it also gives you, the GNMI gives you the ability to subscribe to various different subtrees of the Yang tree, and gives you, and that plays a really important role when you want to gather telemetry or subscribe to some changes. And it's much better than using SNMP, long story short. So, to summarize it, the GNMI interface is available as an implementation on the GitHub. You can use it with OpenDaylight. And yeah, so that gives you basically a great start to building a reliable automation or orchestration platform, as we use it in Pantheon. And even though GNMI is not so powerful as netconf, but we're dealing here with switches, so some trade-offs are expected. So the GNMI, I think, is a really good trade-off in this case. There was a great question on LinkedIn from some company. Why should I care? What is it good for? What is it all about? I hope it wasn't some chatbot AI asking that question. So if it was a chatbot, then this is a slide for you, if you're be hearing this presentation. So some of the use cases that you can use the GNMI subband plugin in OpenDaylight is the network service abstraction. You can model your network service and then translate it to the device-specific configuration. So basically model-to-model translation, or if you have a customer and SONiC only supports like a SONiC model or OpenConfig model, then you can create a model-to-model translation by using a OpenDaylight microservice to translate that configuration changes or telemetry streaming from the device to that third-party system. What it provides is also the configuration data store. So you could, in theory, create a snapshot of the configuration from SONiC, store it there, do the operations within OpenDaylight, create a snapshot of the whole configuration, do some changes, recalculate what are those changes. If something fails during the configuration of the device, then recalculate what needs to be changed back. So you can use, and that's one of the options how we are using OpenDaylight at the moment, is to implement the network-wide transactions. Because GNMI only supports two-phase commit, you only have ability to roll forward. When something fails and you want to do configuration change on multiple devices, and some of the devices failed, then the only thing you can do is basically get back to a previous state. So you can get a snapshot of the previous configuration, recalculate what was the changes, and then basically roll forward to a previous configuration on the device. And that's how we're using it to do the network-wide transaction for SONiC. And the demo that was presented at the SONiC booth was a pre-built application, which is a protocol bridge containing the REST-conf on a northbound and then GNMI on the southbound. By using this application, you can run it in a container, and you can use it, for instance, for the role-based access control if you want to have a more granular access to the individual subtrees of the Yang tree. So you can use some of your own. If you're using Kubernetes, then you can attach some policies to certain paths and allow some users to do just some things. So you can extend the ECL model by using this simple application. And as well, it provides you a more understandable way of integration with third-party systems. So if you have Java developers, they probably understand REST, so you can have a easier way to integrate with a third-party system, whether it is some workflow engine or ticketing system, etc. And last but not least, the separation of concern, which allows you to have a separate container. And if you want to have a multi-current access to the SONiC, then you probably don't want to have 30 users talking to the single device. So you want to have a single application that manages all the sessions, and then you can that allows you basically to scale also the multi-currency when you're dealing either with the telemetry or with the configuration changes. If there are any other use cases that you could think of, then please reach out. We'll be happy to hear them. And that's it for today. Maybe if we have some questions, then feel free to ask.
How much of the SONiC functionality is actually existing in the OpenDaylight current support?
Well, it's just about, well, there are two ways how to integrate. One of the integrations is GNMI. So the GNMI, we already implemented the protocol. It's a really simple protocol. And it is currently, we have a wiring with the OpenDaylight MDSAL layer. So that allows us to do the mapping like the REST-conf to NetConf. So if you take a look on the project, there is like a definition of the bindings in between the REST-conf and NetConf. When you do delete, then it translates to some GNMI operation, etc. So there is a mapping of those protocols. And yeah, that's basically it. There is no code in SONiC that requires that is required by OpenDaylight. So it is using just the GNMI implementation in SONiC.
Yeah, but on feature level, STP, routing, all those modules, right? The features, are all the features already built?
As I mentioned, the OpenDaylight is a platform, so you can build the use cases.
So we need to build it.
Yes, yes. There isn't like a pre-built application that you could use. Within the BGP PSET project, there are like a topology calculation algorithms. So, but for that, we would need to implement in SONiC the BGP-LS protocol for the layer 3 topology discovery, and integrate and use the integration not by using GNMI, but the PSET and BGP. So, in this case, we're talking about changing configuration, subscribing to the telemetry, and monitoring basically the operational state of the Redis by using the GNMI interface, which is a well-defined programmable API available in SONiC. If it makes sense. All right, perfect. Thank you very much.